I'm Josh Busby, professor here at the University of Texas. My co-author and I, Paul Orsog, wrote this short paper on U.S. national security risk of dependence on China for battery and solar technologies. Rising geostrategic competition between the U.S. and China has raised concerns that the U.S. and other Western states are overly dependent upon inputs from Chinese suppliers, posing an unacceptable risk to U.S. national security. A study in Science by Davidson et al. Surveyed various clean energy technologies and assessed the economic and national security risk of interdependent supply chains between the U.S. and China and the consequences of decoupling their economies. Relative to other sectors, they found limited national security risks overall, with the greatest risks economic in nature in solar, photovoltaics, and batteries, given China's dominance of minerals extraction, refining, and manufacturing processes. While this is an important contribution, the study may understate the national security consequences of dependence, suggesting more direct efforts through U.S. national industrial policy may be warranted. Our memo seeks to explore the national security risks of dependence in those two sectors in greater detail by 1. Surveying the nature and extent of U.S. dependence on China and solar and batteries, 2. U.S. policies to date, and 3. Whether this dependence constitutes a national security risk, drawing from examples of other energy and technological dependence. The first section of the memo tries to substantiate the degree of dependence of the U.S. on China for different minerals and minerals processing related to clean energy technologies, as well as the components and finished products for batteries and solar. The second section surveys the range of policies that the U.S. government has embraced to try to reduce supply chain vulnerabilities, including the Inflation Reduction Act, a 100-day supply chain review, the Defense Production Act, lists of critical minerals, and more. The third section reviews the risks of interdependent supply chains. We start by noting the risks of more extensive decoupling for the clean energy transition, the potential for trading one resource dependency for another in the competition for critical minerals, and then the broader potential for U.S.-China conflict if economies are less tightly coupled. But the bulk of that section reviews the arguments for whether U.S. dependence on China for raw materials, processing, and finished products for batteries and solar are national security risks. We review the variety of arguments that Davidson et al. Discuss in their paper: risk to critical infrastructure, dual-use technologies, and energy security. For battery and solar, Davidson et al. Regard the national security risks as mostly low. For example, unlike oil, which requires constant resupply, there's no risk to existing energy resources if China were to withhold minerals, intermediate components, or finished products in the wake of a conflict over Taiwan, for example. Rather, the risks would delay the energy transition as inventories run down and orders can't be filled. They do regard supply chain risks as higher for both batteries and solar, thus an argument for some diversification of supply and domestic production. But supply chain arguments are economic in nature in their view. Using the parallel of computer chips, we take a slightly different tack. We note that battery and solar technologies will likely be a major driver of economic development for the United States in the years to come, and that national economic competitiveness will provide the resources to support military capability. From that perspective, allowing a peer competitor to control all of that supply chain would undermine the country's growth potential. This puts us on the side of there being more national security risks of interdependent supply chains than Davidson et al., which would suggest more ally shoring and more domestic production is warranted. But there's a balance. Benchmark source suggests no more than 3 or 4% of domestic cathode and anode demand will be produced in North America by 2030. So the U.S. is still going to need a lot of imports, probably from China in the short run. It also means that the U.S. should take advantage of Chinese technology advances and capital where it can, particularly from firms that are in good standing with the U.S. government. We're probably closer to the perspective of, say, Governor Whitmer in Michigan, who has supported a new battery plant from Ford that benefits from a licensing agreement with the Chinese firm CATL. Contrast this with Governor Youngkin of Virginia, who pulled his state from contention for a Ford-CATL joint venture. I think the key thing is, can the U.S. manufacturers gain insight into advanced battery technologies through such partnerships? Where that is possible, the benefits may outweigh the risks. We look forward to discussing this in the wider workshop. Thank you.